close your eyes and imagine this. Right now, in the 21st century, we have detailed records of nearly everything. What you ate for breakfast, your search history, satellite images of your house from space. We track everything. Go back 500 years and we've got written records, paintings, artifacts. Go back 2,000 years to ancient Rome and we've still got incredible documentation. Buildings, coins, entire libraries of text. Push back to 5,000 years ago and we're looking at the first cities, the earliest writing systems, the dawn of what we call civilization. But here's where it gets weird, really weird. Anatomically modern humans, people who looked exactly like us, with brains just as capable as ours, have existed for roughly 300,000 years, maybe longer. That's 300,000 years of human beings walking around with the same biological hardware you're using right now to understand these words, the same capacity for language, problem solving, creativity, planning. Yet our entire recorded history, everything we call civilization, only goes back about 5,000 years. Do the math. That means 99% of modern human existence is just missing, gone. A vast empty space in our past that we know almost nothing about. 295,000 years of anatomically modern humans doing what exactly? That's not a gap. That's a canyon, an abyss, a prehistoric time gap so enormous it should keep you up at night. Except you're here to fall asleep, which is perfect, because that's exactly why I make these videos. If you're using this to drift off, go ahead and subscribe. And here's something I love. Comment and tell me where you are and what time it is right now. I read through them and it's genuinely mind-blowing. Tokyo at sunrise, London at midnight, Chicago during lunch break, all watching the same video at the same moment across completely different realities. There's something beautiful about that. But back to this mystery that refuses to make sense. See, the standard story you learned in school goes something like this. Early humans were primitive hunter-gatherers, basically clever apes, wandering around in small groups for hundreds of thousands of years. They made simple stone tools, lived in caves, struggled to survive. Then, suddenly around 10,000 years ago, boom, agriculture, civilization, writing, cities, pyramids. The whole package just appeared, and we've been advancing ever since. It's a nice, clean narrative. Is also looking more and more like it might be completely wrong. Because the deeper scientists dig, literally and figuratively, the more evidence they find that doesn't fit. Ancient structures that shouldn't exist yet. Astronomical knowledge encoded in prehistoric sites that seems impossibly sophisticated. Genetic bottlenecks that suggest humanity went through catastrophic events we have no memory of. Population patterns that make no mathematical sense. Technologies and techniques that appeared fully formed with no clear development process. It's like finding a smartphone in a medieval painting, except we keep finding more and more smartphones and nobody can explain how they got there. The archaeological record is screaming at us that something's missing. Some crucial chapter of human history got erased, lost, buried under ice, or ocean, or time itself. And the really unsettling part? Multiple ancient cultures from around the world, civilizations that supposedly never contacted each other, all tell eerily similar stories. Stories of great floods, advanced ancestors, lost golden ages, knowledge passed down from before. Before what? Before the world changed, before the disaster, before the forgetting. Most scientists dismiss these stories as mythology, imagination, primitive attempts to explain a confusing world. But what if they weren't? What if scattered throughout these ancient tales are fragments of actual memory? Evidence of a human story far more complex and mysterious than we ever imagined. Tonight, we're going deep into this gap, this impossible, fascinating, frustrating hole in our history. We're going to explore the mind-bending theories trying to explain it, the hard evidence that mainstream archaeology struggles to account for, the ancient sites that seem to defy everything we think we know about prehistoric humans, the technologies that appeared thousands of years too early, the genetic mysteries written in our DNA, the underwater ruins that suggest coastlines looked very different when they were built, the astronomical knowledge that shouldn't exist yet. And here's what makes this perfect for falling asleep. These aren't questions with simple answers. They're deep, slow mysteries, the kind that let your mind wander and drift, the kind that don't demand you stay alert. Just let the information wash over you. Let the mystery settle into your thoughts as you drift off. Because whether you're here to learn or just to find some peace before sleep, this story works either way. We're about to journey back through that vast, dark, unexplained gap in human history, and I promise you, by the end, you'll never think about our past quite the same way again. So get comfortable. Let's dive into the prehistoric time gap that science still can't explain. Now here's where the story gets really strange. Because everything I've just told you about the bottleneck, about the near extinction, about the splitting into 3 species, that all happened hundreds of thousands of years before modern civilization appeared, and that creates one of the most baffling mysteries in all of human history. Your brain, the one you're using right now to follow this story, is anatomically identical to the brains of humans who lived 300,000 years ago. Same size, same structure, same potential for complex thought, creativity, problem solving. If you could somehow transport a baby from 300,000 years ago to the present, raise them in a modern home, send them to modern schools, they would be completely indistinguishable from any other child. They could learn calculus, speak multiple languages, become doctors or engineers or artists. Their brain would be just as capable as yours. So here's the question that should be keeping scientists awake at night. If humans have had modern brains for 300,000 years, why did civilization only appear 10,000 years ago? What were we doing for the other 290,000 years? This is what anthropologists call the anatomically modern human paradox. And it's not just about brain size. The archaeological evidence shows that early humans were demonstrably intelligent. They weren't primitive ape men stumbling around in the dark. They were us, with all our cognitive potential, just living in a very different world. Consider the tools. By 200,000 years ago, humans in Africa were creating sophisticated stone tools that required extensive planning and skill to manufacture. They were using heat treatment to alter the properties of stone, making it easier to work. This is material science. They had to understand that heating certain rocks to specific temperatures would change their molecular structure in useful ways. That's not instinct. That's experimentation, knowledge accumulation, and teaching. By 100,000 years ago, they were making composite tools, hafting stone points to wooden shafts using adhesives made from tree resins. They had to find the right trees, extract the resin, possibly heat it to the correct consistency, and apply it at just the right moment in the construction process. This requires forward planning, multi-step reasoning, and the ability to hold complex procedural knowledge in mind while executing each step. And then there's the art. In Blombos Cave in South Africa, archaeologists found pieces of ochre engraved with geometric patterns dating to 73,000 years ago. These aren't random scratches. They're deliberate repeated patterns that show planning and aesthetic intention. Someone sat down with a piece of ochre and carefully carved abstract designs into it. Why? What was the purpose? We don't know. But the fact that they did it at all tells us they were capable of symbolic thinking, of creating meaning beyond immediate survival needs. Shell beads, carefully drilled and strung together, appear in the archaeological record starting around 100,000 years ago. Personal adornment, fashion, social signalling. These people weren't just trying to survive, they were thinking about status, identity, group membership. They were creating culture. By 40,000 years ago, humans were creating elaborate cave paintings in Europe, intricate carvings in Asia, sophisticated burial practices that show they had developed complex belief systems about death and the afterlife. They were making musical instruments, telling stories, almost certainly speaking fully modern languages. So what's the problem? The problem is that for hundreds of thousands of years, despite having all this cognitive capacity, despite being demonstrably intelligent and creative, human populations remained small. Technology advanced but slowly, incrementally. There were no cities, no agriculture, no writing, no mathematics. None of the things we associate with civilization. From 300,000 years ago to about 10,000 years ago, humans lived in small groups, moving seasonally, hunting and gathering, creating tools and art, but never building anything that lasted, never accumulating knowledge into the kind of explosive technological growth we've seen in the last few thousand years. Why? What was holding us back? Some scientists think the answer lies in population size. Small groups living in isolation can innovate, but their innovations often die with them. There's no critical mass of people to maintain and build on new ideas. Every generation has to relearn what the previous generation knew. Progress happens, but it's fragile, easily lost when groups die out or migrate to new territories. But others think something more dramatic was at play, something that not only kept populations small, but actually reset human progress multiple times, forcing survivors to rebuild from almost nothing. Enter the Toba Catastrophe. 74,000 years ago, Mount Toba in what is now Indonesia erupted with the force of 1,000 nuclear weapons. It wasn't just a volcanic eruption, it was a supervolcano, one of the largest explosive events in the last 2 million years. The eruption ejected so much ash and sulfur dioxide into the atmosphere that it likely triggered a volcanic winter lasting 6 to 10 years. Temperatures dropped. Sunlight was blocked. Plant life died off across vast regions. The animals that depended on those plants starved, and the humans who depended on those animals faced extinction. The genetic evidence suggests something catastrophic happened around this time. When geneticists analyze human DNA, looking at the variation between different populations, they find something shocking. Humans have remarkably low genetic diversity compared to other species. Chimpanzees, our closest living relatives, have 3 to 4 times more genetic variation than we do, despite having much smaller populations. This lack of diversity suggests a recent bottleneck, a moment when human population crashed to a tiny fraction of its previous size. The Toba eruption is the perfect candidate for this event. Some estimates suggest that human population might have dropped to as few as 3,000 to 10,000 individuals worldwide. That's it. Fewer people than currently live in a small town, scattered across an entire planet that had just become almost uninhabitable. These weren't different groups living in different places. These were the only humans left. Everyone alive today, is descended from that tiny population of survivors. Think about what that means for a moment. Every human innovation, every tool design, every piece of knowledge about where to find food or how to make fire, all of it was carried in the minds of maybe 10,000 people struggling to survive in a world covered in ash. How much knowledge was lost? How many innovations simply disappeared because the people who knew them died before they could pass them on? Maybe humans had been on the verge of something greater before Toba. Maybe populations were growing, trade networks were expanding, technologies were becoming more sophisticated, and then the volcano erupted and wiped almost all of it away, leaving only scattered survivors who had to focus on basic survival rather than innovation. The bottleneck might explain why human progress seems frozen for so long. We weren't frozen. We were repeatedly set back to almost zero, forced to rebuild again and again from the knowledge carried by a handful of survivors. But here's what makes this even more interesting. The bottleneck didn't make us weaker, it made us stronger. The humans who survived Toba weren't random individuals. They were the ones smart enough, adaptable enough, cooperative enough to make it through the worst environmental disaster in human history. Natural selection compressed into a few desperate generations, favouring every trait that enhanced survival. When populations finally began to recover after Toba, these survivors carried genes that had been ruthlessly selected for intelligence, social cooperation, and adaptability. Their descendants spread out from whatever refugees had sheltered them, carrying enhanced cognitive abilities and stronger social instincts than their pre-Toba ancestors. Maybe this is why behavioural modernity appears so suddenly in the archaeological record around 50,000 to 60,000 years ago. Not because humans suddenly evolved new capabilities, but because the post-Toba population finally reached critical mass. Enough people, spread across enough territory, maintaining enough connections to create self-sustaining innovation networks. For the first time in human history, new ideas could spread faster than they could be lost. Technologies could build on previous technologies. Cultural knowledge could accumulate rather than being repeatedly wiped out. But even with all this, even with enhanced intelligence and growing populations, humans still didn't create what we would recognize as civilization. No cities, no empires, no written records. For another 40,000 years, humans remained hunter-gatherers, living in small groups, moving with the seasons, creating art and tools and culture, but never settling down, never building permanent structures that would last millennia. The paradox deepens, because clearly these people had the cognitive capacity for civilization. Their brains were identical to ours. The Toba survivors and their descendants were smart enough to create everything we've created. So why didn't they? Was it just that the conditions weren't right? That you need agriculture before you can have cities, and agriculture only became possible or necessary when climate conditions changed after the last ice age? Or is there something else, something we're missing in the archaeological record? Some development that happened but left no trace, or left traces in places we haven't looked yet. Because here's the uncomfortable truth that the anatomically modern human paradox forces us to confront. For 290,000 years, humans who are just as smart as us, just as creative, just as capable, lived and died without creating anything like modern civilization. And we don't really know why. We have theories, educated guesses, reasonable explanations, but we don't know. And if we don't know why they didn't build civilizations, how can we be sure they didn't? How can we be certain that in 290,000 years, in all that vast expanse of time, nothing was built that has since been lost? that no knowledge was accumulated that has since been forgotten, that our ancestors never achieved anything we would find remarkable, only to have it swept away by the next climate disaster, the next volcanic winter, the next great dying. The anatomically modern human paradox isn't just about explaining why civilization appeared so late. It's about confronting the uncomfortable possibility that we might not know the full story of what humans achieved, what they built, what they knew in all those long millennia before recorded history began. And as we're about to see, there's evidence that suggests our ancestors might have been more accomplished than we ever imagined. But what if everything we think we know about prehistoric human civilization is wrong? Not slightly off. Not just missing a few details. What if entire chapters of human history are literally underwater, erased from the archaeological record by forces so massive they reshaped continents? Because here's something that doesn't get talked about enough. During the last ice age, which ended just 11,700 years ago, sea levels were 400 feet lower than they are today. That's the height of a 40-story building. 400 feet of vertical space that's now ocean was once dry land, habitable land, prime real estate for human settlement. Think about where humans naturally settle. Not mountain tops, not deep inland plateaus. Throughout all of recorded history, humans have consistently chosen coastal areas, river valleys, places where land meets water. It's not hard to understand why. Water means fish, shellfish, transportation routes, trade opportunities. The most productive ecosystems on Earth are coastal zones, where terrestrial and marine resources overlap. Today, more than 40% of the world's population lives within 60 miles of a coastline. There's no reason to think prehistoric humans were any different. Now here's the problem. If sea levels rose 400 feet at the end of the Ice Age, then any coastal civilizations from that period are now underwater. Not just their port facilities or beach houses, their entire territories. Everything within dozens, sometimes hundreds of miles of what they would have known as coastline is now beneath the waves. We're not talking about small patches of land. We're talking about land masses the size of countries, entire continents that existed during the Ice Age and were swallowed by rising seas when the glaciers melted. Take Doggerland. For most of human history, Britain wasn't an island. It was connected to continental Europe by a vast landmass that stretched from what's now England to Denmark and the Netherlands. This wasn't some narrow land bridge. Doggerland covered an area roughly the size of modern Britain. It had hills and valleys, forests and wetlands, rivers that don't exist anymore and lakes that vanished when the seas rose. We know about Doggerland because fishing trawlers keep dragging up evidence. Mammoth bones, ancient tools, worked flints, fossils of animals that haven't lived in that region for 10,000 years. In 1931, a fishing boat pulled up a beautiful barbed antler point, clearly manufactured by human hands, from 25 miles off the coast of Norfolk. The Doggerland Point, as it's now called, was dated to around 10,000 BCE. But here's the thing. That fishing net could have been dropping anywhere in thousands of square miles of ocean floor, which means that single artifact represents just one tiny point in what must have been a vast populated landscape. How many other sites are down there? How many settlements, workshop areas, ceremonial centres? We'll never know, because investigating underwater sites is exponentially more difficult and expensive than traditional archaeology. Most of Doggerland will remain unexplored, its secrets preserved in darkness beneath the North Sea. But at least we know Doggerland existed. We can map its topography using seafloor sonar, model what the landscape looked like, estimate where people might have lived. What's more disturbing is thinking about all the other drowned landscapes we haven't even identified yet. All the land masses that disappeared when the Ice Age ended and haven't left convenient artifact fields for fishing boats to sample. Consider this. When sea levels were 400 feet lower, the entire continental shelf was exposed. The continental shelf is that relatively shallow underwater plain that extends outward from continents before dropping off into the deep ocean. During the Ice Age, this wasn't shelf, it was land. Thousands upon thousands of square miles of prime real estate, all of it now submerged. In Southeast Asia, the shelf exposure connected islands that are now separated by hundreds of miles of ocean. Indonesia, Malaysia, and parts of Thailand formed a massive landmass called Sunderland, roughly the size of India. In Australia, the continental shelf exposure made the continent nearly 30% larger than it is today, connecting Tasmania and extending the coastline hundreds of miles beyond its current position. All of this land was available for human habitation, and based on what we know about human settlement patterns, it was probably densely populated, at least by prehistoric standards. So where's the evidence? Where are the ruins? Mostly they're gone. When you flood a landscape, especially one that's been underwater for 11,000 years, the archaeological record doesn't just get hidden, it gets destroyed. Sediment accumulates, currents erode structures, marine organisms colonize surfaces, breaking them down. Wooden structures rot away completely. Even stone buildings crumble under the relentless action of water and time. But not everything disappears, and that's where the story gets really interesting. Because scattered around the world in waters that were once dry land, there are structures that shouldn't be there. Formations that look too regular, too purposeful to be natural. And they're located in places that align perfectly with where human settlements would have been during the Ice Age. The most famous is the Yonaguni Monument, off the coast of Japan. In 1987, a dive tour operator named Kiichiro Aratake was exploring waters near Yonaguni Island, looking for good spots to observe hammerhead sharks. Instead, he found something that would launch decades of controversy. Massive stone formations that look unnervingly like terraced pyramids, flat platforms connected by right-angle steps, long straight edges, carved channels, formations that seem to show tool marks and deliberate shaping. The site covers about 50,000 square meters and rises from a depth of 25 meters up to about 5 meters below the surface. Marine geologist Masaki Kimura from the University of the Ryukyu spent years studying the formation. His conclusion: it's a man-made structure, constructed when sea levels were lower, then submerged when the Ice Age ended. Based on geological dating of when that area was last above water, that would make the Yonaguni Monument at least 10,000 years old, possibly older. Mainstream archaeology doesn't buy it. The general consensus is that Yonaguni is a natural formation, created by tectonic activity and erosion. The parallel lines, geological fractures, the right angles, chance alignments of natural rock layers, the apparent tool marks, wishful thinking and pattern recognition. But here's where it gets complicated. Nobody disputes that the formations exist. The question is whether they're natural or artificial, and that question is harder to answer than you might think. Because when you're dealing with structures that have been underwater for 10,000 years, the line between natural and artificial becomes blurry. Did humans find natural formations and modify them? Did they build entirely new structures? Or are we looking at nothing but geology and seeing what we want to see? The debate continues because nobody can definitively prove it either way. To confirm human construction, you'd need clear evidence of tool marks, quarrying techniques, or construction methods that couldn't occur naturally. But 10,000 years of submersion has eroded or obscured exactly the kind of fine detail that would prove human involvement. It's the perfect unsolvable mystery. Suggestive enough to inspire endless speculation, ambiguous enough that conclusive proof remains just out of reach. And Yonaguni isn't alone. Off the coast of India, in the Gulf of Kambat, sonar surveys in 2001 identified what appeared to be regular geometric patterns on the seafloor. Long straight formations, right-angle intersections, rectangular depressions. The Discovery team from India's National Institute of Ocean Technology dredged up artifacts from the site. Pottery fragments, beads, pieces of worked wood. They announced that radiocarbon dating placed some of the wood fragments at 9,500 years old. If confirmed, this would represent evidence of a substantial settlement that predates the earliest known Indian civilizations by more than 5,000 years. The Gulf of Kambat discovery suggests that sophisticated urban centres existed in South Asia thousands of years before we thought complex civilization emerged in that region. But again, controversy erupted. Other researchers questioned the dating methodology. They pointed out that wooden fragments can drift with currents, meaning old wood doesn't necessarily prove old structures. These sonar images, while suggestive, weren't clear enough to definitively show artificial construction. The Indian government's decision to restrict access to the site for further research didn't help matters. Without independent verification, the Gulf of Kambat remains tantalizing but unproven. Similar claims emerge regularly from underwater sites around the world. Stone formations off the coast of Cuba that some researchers interpret as roads and buildings, regularly spaced stones off the Bimini coast in the Bahamas, apparently artificial structures in the Mediterranean, off Japan near Taiwan. Each discovery sparks the same cycle: initial excitement, mainstream skepticism, endless debate, no resolution. Here's what we can say with certainty. The underwater landscape is vastly underexplored. We've mapped more of the moon's surface than we have of Earth's ocean floor. The technical challenges of underwater archaeology are immense. Visibility is often measured in feet, not miles. Working time is limited by dive constraints. Equipment is expensive. Funding is scarce. Most institutions focus their resources on traditional terrestrial sites where the archaeology is clearer and the logistics are simpler. This creates a massive sampling bias in our understanding of prehistory. We've thoroughly explored inland sites, places that were never threatened by rising seas, but we've barely scratched the surface of coastal areas where the majority of humans probably lived. It's like trying to understand modern civilization by only excavating in Death Valley and never investigating New York, London, or Tokyo. The mathematical improbability of having found all major prehistoric sites becomes obvious when you think about the numbers. Archaeological surveys have covered maybe 10% of terrestrial areas where prehistoric humans are known to have lived. That's 10% of the land that's still above water. For the continental shelves, the drowned coastlines where Ice Age humans almost certainly concentrated, we've explored far less than 1%, probably less than 0.1%. What are the odds that the 1% of sites we've actually investigated represent the full scope of prehistoric human achievement? Essentially zero. It would be like future archaeologists studying 21st century civilization but only having access to rural Kansas. They might find farmhouses and small towns. What they wouldn't find are cities, universities, spaceports, or anything that reveals the true complexity and sophistication of our society. The same logic applies to prehistory. The sites we've found, impressive as they are, might represent the countryside of ancient civilizations. Their true centers, their great cities and ceremonial complexes, might be hundreds of feet underwater, buried under sediment, invisible to archaeology. Now we have to be careful not to jump from "we haven't found everything" to "therefore advanced civilizations existed." Those are two very different claims. Just because something is possible doesn't make it true. The absence of evidence isn't evidence of presence, but it is evidence of ignorance. And that's the point. We don't know what's down there. We don't know what the full scope of prehistoric human achievement was. We've explored enough to know that humans were doing surprising things much earlier than we thought. Gobekli Tepe, which we'll discuss in detail later, proved that humans were building massive stone complexes 11,600 years ago, millennia before agriculture was supposed to have made such projects possible. If something that's sophisticated existed inland, what existed on the coasts? What engineering feats, what astronomical observations, what accumulated knowledge might have been achieved by coastal populations who had the advantage of trade routes, abundant resources, and the economic surplus that coastal living provides? The end of the Ice Age wasn't a gradual, gentle process. It was catastrophic. Sea levels didn't rise steadily over thousands of years. They rose in pulses, sometimes jumping 10 or 20 feet in a single century as massive ice dams broke and glacial lakes drained into the ocean. Around 8,200 years ago, the final drainage of Glacial Lake Agassiz in North America released so much fresh water into the North Atlantic that it temporarily disrupted ocean currents and caused a global cooling event. Imagine living through that. You're a member of a coastal community, perhaps a society that's been developing for thousands of years. Your ancestors have lived in the same region for hundreds of generations. You have fields, settlements, ceremonial centers. Then, over the course of a few generations, the sea begins to rise. Not dramatically at first, a few inches a year, easy to ignore, but it doesn't stop. Year after year, decade after decade, the ocean advances. Fields become salt marshes. Villages have to be abandoned. Sacred sites disappear beneath the waves. Eventually, you're forced to retreat inland, away from the resources and trade routes that made your civilization prosperous. Your population fragments. Knowledge is lost. The sophisticated society your great-grandparents knew collapses into scattered survivors trying to adapt to unfamiliar inland territories. This scenario played out all over the world as sea levels rose by 400 feet over roughly 10,000 years. It was slow enough that humans could migrate ahead of the rising waters, but it was fast enough that entire ways of life were lost. Entire landscapes containing who knows how many generations of human achievement were drowned and forgotten. The survivors would have kept stories, flood myths, tales of lost homelands, memories of ancestors who lived in places that no longer existed. And if you look at mythology from around the world, that's exactly what you find. Stories of great floods, narratives of civilizations destroyed by rising waters, common themes that appear in cultures separated by thousands of miles and thousands of years. Are these myths just coincidence? Or are they cultural memories of real events, transmitted through countless generations, distorted by time but preserving a kernel of truth about the catastrophe that ended the Ice Age? We don't know. And that's the most honest answer archaeology can provide. The evidence exists, fragmentary and ambiguous, scattered across ocean floors we've barely explored. The hypothesis is plausible. The timeline matches. The mechanism makes sense, but proof remains elusive, hidden beneath hundreds of feet of water, buried under thousands of years of sediment, waiting for a level of underwater archaeological investigation we haven't yet achieved. The civilizations that might have existed during the Ice Age aren't lost because they weren't real. They're lost because they were in the worst possible location, right on the coastline, right where rising seas would destroy them most thoroughly. And until we develop the technology and commit the resources to properly explore the drowned world, they'll remain where they are, in the dark, in the cold, beneath the waves. Silent witnesses to chapters of human history we can barely imagine and may never recover. Now, we need to talk about the discovery that broke archaeology, not bent it, not challenged it, broke it completely, shattered centuries of carefully constructed theories about how civilization began, and forced scientists to acknowledge something that makes most of them deeply uncomfortable. There's a massive gap in our understanding of prehistoric human capability, and sitting right in the middle of that gap is a mountain in Turkey that nobody paid attention to for thousands of years. Until 1994. That's when a German archaeologist named Klaus Schmidt looked at a hill called Gobekli Tepe, which translates roughly to Potbelly Hill, and decided to actually dig into it. Local farmers had been finding carved stones there for generations, but everyone assumed it was just an old Byzantine cemetery. Nothing special. Schmidt thought differently. He had this nagging suspicion that the hill wasn't natural, that it was hiding something. So he started excavating. What he found in the first few days of digging should not exist. Massive stone pillars, not small rocks, not crude markers. Pillars weighing up to 16 tons each, carved from solid bedrock, transported somehow to this hilltop and erected in perfect circles. Each pillar was decorated with elaborate carvings. Animals, abstract symbols, human-like figures with their hands positioned as if they were participating in some kind of ritual. The artwork wasn't primitive. It was sophisticated, detailed, showing artistic skill that would have taken generations to develop. But here's the thing that made Schmidt stop breathing for a moment. When he dated the site, when he used every available method to figure out how old these structures were, he got an answer that didn't make sense. 11,600 years old, not 6,000, not 8,000. 11,600 years ago. This meant Gobekli Tepe was built roughly 6,000 years before Stonehenge, 7,000 years before the Egyptian pyramids. At a time when every history textbook says humans were supposed to be primitive hunter-gatherers, barely surviving, living in small nomadic bands, with no capacity for large-scale organization or monumental construction. According to everything we thought we knew about human development, the people who built Gobekli Tepe shouldn't have existed. Not with that level of skill, not with that degree of social organization, not with the astronomical knowledge they clearly possessed. Because these weren't just pretty circles of stones. The pillars were aligned, precisely aligned to track celestial events, solstices, equinoxes, possibly even the precession of specific star systems. The carvings themselves seem to encode astronomical information. Some researchers think they represent a map of the ancient night sky, showing constellations as they appeared 13,000 years ago. One carved pillar, called the Vulture Stone, appears to depict a comet impact event, possibly the Younger Dryas comet that triggered global climate catastrophe around 10,800 BCE. Think about what this means. The conventional narrative of human civilization goes like this. First, humans learned agriculture. Then, because farming created food surpluses, people could settle in one place. Then, because settled communities had more resources, they could support specialized workers. Then, and only then, could they build monuments. Agriculture leads to settlement, leads to specialization, leads to architecture. That's the pyramid of civilization. Every anthropology textbook teaches it. Gobekli Tepe destroys this model completely. The people who built this site weren't farmers. There's no evidence of agriculture at Gobekli Tepe. None. No domesticated plant remains. No agricultural tools, no storage facilities for grain. The animal bones found at the site come from wild species. Gazelles, wild cattle, wild pigs. These were hunter-gatherers, people who shouldn't have had the ability to organize hundreds, maybe thousands of workers to quarry, transport and erect massive stone pillars. But they did it anyway. The construction itself is mind-boggling. Each of those 16-ton pillars had to be quarried from bedrock using stone tools, not metal, stone. Then they had to be transported somehow to the hilltop. Some of these pillars came from quarries over a quarter-mile away. You try moving a 16-ton block of stone a quarter-mile using only Stone Age technology and see how it goes. Then they had to be lifted upright and positioned precisely. The pillars stand in circles, perfectly spaced, with the tops carved into T-shapes that suggest they might have supported roofing or additional structures. The whole complex isn't just one circle either. Initial excavations revealed multiple circular structures, each with its own arrangement of pillars. Ground-penetrating radar suggests there are at least 20 circles in total, most still buried. The visible structures represent maybe 5% of the site. And here's where it gets even stranger. After Gobekli Tepe was used for perhaps 1,000 years, someone deliberately buried it, not abandoned it, not let it decay naturally, buried it, carefully, systematically, filling in the circles with tons of rubble and soil. Someone went to enormous effort to hide this place, to preserve it underground. Why? What were they protecting? Or what were they trying to forget? Klaus Schmidt spent the rest of his life trying to answer these questions. He died in 2014, and the excavations continue today, but every new discovery raises more questions than it answers. Because Gobekli Tepe isn't unique, it's just the largest, the oldest, and the most intact example of something that's showing up all over the world. In Turkey alone, dozens of similar sites have been identified from the same period. Karahan Tepe, Harbet Tepe, Sefer Tepe. Each one features megalithic construction with astronomical alignments and sophisticated carved symbols, all built by supposedly primitive hunter-gatherers who couldn't possibly have had the knowledge or organization. But it's not just Turkey. Similar megalithic structures from roughly the same mysterious period keep appearing globally. Malta has temple complexes dating back 11,000 years with advanced acoustic engineering. The builders somehow designed chambers that amplify specific sound frequencies, possibly for ritual purposes. This requires understanding of acoustics that most modern architects don't possess. Indonesia has Gunung Padang, a massive pyramid structure that recent dating suggests might be over 20,000 years old, though this remains controversial. If true, it predates any known civilization by more than 10,000 years. The Bimini Road in the Bahamas, massive stone blocks arranged in geometric patterns underwater, potentially dating to when that area was above sea level, over 12,000 years ago. The ruins of Yonaguni off the coast of Japan, showing what appears to be artificial stone cutting and arrangement, possibly from a similar period. Even in North America, sites like Poverty Point in Louisiana show surprisingly sophisticated engineering from indigenous peoples long before conventional timelines suggested such capability existed. All of these sites share certain characteristics: megalithic construction using stones far larger than necessary, astronomical alignments that demonstrate detailed celestial knowledge, symbolic artwork that suggests complex religious or philosophical systems, and they all date to roughly the same period, between 12,000 and 10,000 years ago. This is the period immediately after the Younger Dryas, the most recent and one of the most severe climate catastrophes in human history. For over 1,000 years, from about 10,800 to 9,600 BCE, global temperatures plummeted. Ice sheets that had been retreating suddenly advanced again. Sea levels dropped and then rose rapidly. Ecosystems collapsed. Many large animal species went extinct. It was a global disaster. And then, immediately after it ended, these sophisticated structures start appearing everywhere. Almost like some group of people who'd survived the catastrophe, suddenly decided to build permanent monuments, to encode knowledge in stone, to create structures that would last, that would survive whatever catastrophes might come next. This is where conventional archaeology starts getting really uncomfortable, because the implication is obvious. If hunter-gatherers built Gobekli Tepe, if they possessed the astronomical knowledge, the organizational capability, and the construction skills to create these monuments, where did they learn these things? You don't just wake up one morning and decide to build a 16-ton astronomical observatory. These skills take generations to develop. The astronomical knowledge encoded in these sites requires centuries of careful observation and record-keeping. The construction techniques require accumulated engineering experience passed down through apprenticeships and teaching systems. This suggests there was a sophisticated culture before Gobekli Tepe, a culture that developed these capabilities over long periods, a culture that was then disrupted, possibly destroyed by the Younger Dryas catastrophe, and the survivors, the people who remembered the old knowledge, built these monuments as a way to preserve what they knew for future generations. Some researchers call this the lost civilization hypothesis, the idea that there was an advanced culture, not necessarily with our level of technology, but with sophisticated knowledge of astronomy, engineering, and mathematics, that existed before the known dawn of civilization, a culture that was wiped out or severely disrupted by climate catastrophe, leaving only scattered survivors who tried to rebuild and preserve what they could. This makes most mainstream archaeologists extremely uncomfortable, because it requires admitting that civilization might be much older than we think, that there might have been rises and falls we don't know about, that the neat linear progression we teach from primitive to complex might be completely wrong. But the stones don't lie. Gobekli Tepe exists. It was built 11,600 years ago by people who aren't supposed to have that capability, and it's not alone. There are dozens, maybe hundreds of similar sites from the same period, most still unexplored or unexcavated. The fundamental question isn't whether these sites exist. They do. The question is what triggered their creation. What knowledge or event caused supposedly primitive humans to suddenly, simultaneously across multiple continents, start building permanent monuments with astronomical alignments and encoded knowledge? Was it simply the end of the Ice Age, allowing human populations to expand and develop in ways they couldn't during the harsh glacial period? That's the conservative explanation. Or was it something else? Were these sites built by survivors of an earlier sophisticated culture, Trying to preserve knowledge through a dark age? We don't know. That's the honest answer. We have the archaeological evidence, the stones, the carvings, the astronomical alignments. But we don't have the full story. We have chapters missing from the book of human history, and Gobekli Tepe is just the first page we've managed to uncover. And here's what keeps archaeologists up at night. If we're wrong about when civilization began, if it's thousands of years older than we thought, what else are we wrong about? How much knowledge did ancient people possess that we've dismissed because it doesn't fit our timeline? The answers might be buried under hills we've walked past for centuries, waiting for someone to dig deep enough to find them. But what if there's another layer to this story? What if something happened that we've been missing all along? A catastrophe so devastating that it nearly wiped the slate clean, erasing evidence of everything that came before it? This is where things get controversial, where mainstream archaeology and alternative researchers clash in bitter disagreement, where the evidence gets murky and the interpretations diverge wildly. But it's also where some of the most compelling mysteries emerge. Graham Hancock calls it the ancient apocalypse theory. The idea that somewhere around 12,800 years ago, an advanced Ice Age civilization was destroyed by a cosmic catastrophe so devastating that it nearly reset human history. And before you dismiss this as fringe pseudoscience, consider that parts of this theory are based on very real, very troubling evidence that mainstream science is still struggling to explain. Let's start with what we know for certain. 12,800 years ago, Earth's climate was in a relatively warm period between ice ages. The great glaciers that had covered much of North America and Europe were slowly retreating. Human populations were expanding. Archaeological sites from this period show increasingly sophisticated tool-making, art, and social organization. Things were, by all appearances, looking up for humanity. Then something catastrophic happened. The geological record shows it clearly. A sudden, dramatic return to near Ice Age conditions. Temperatures plummeting by as much as 15 degrees Celsius in some regions within just a few decades. This cold snap lasted for nearly 1,300 years, a period geologists call the Younger Dryas. And what makes it particularly mysterious is that it happened suddenly, violently, in a way that doesn't fit normal climate patterns. Climate changes in Earth's history usually happen gradually. Ice ages build up over tens of thousands of years as orbital variations alter how much sunlight reaches different parts of the planet. They end gradually too, as those same cycles reverse. But the Younger Dryas was different. It hit like a hammer. One generation living in relatively comfortable conditions, the next facing climate catastrophe. For decades, scientists struggled to explain this. The leading theory was that melting glaciers had disrupted ocean currents, particularly the Gulf Stream, causing the sudden temperature drop. That made sense, fit the data reasonably well, and became the accepted explanation. Then in 2007, a group of researchers led by physicist Richard Firestone proposed something radical. They suggested that the Younger Dryas wasn't caused by ocean currents at all. It was caused by a cosmic impact. Multiple impacts, actually. A fragmenting comet or asteroid that struck Earth in several locations, triggering wildfires, disrupting climate patterns, and causing devastation on a scale that humanity wouldn't see again until the modern era. The evidence they presented was startling. At dozens of sites across North America, Europe, and Asia, researchers found a distinctive layer of sediment dating to exactly 12,800 years ago. This layer, called the black mat by geologists, contains materials that shouldn't be there. Nanodiamonds, microscopic particles that only form under extreme temperatures and pressures. magnetic spherules, tiny balls of melted rock that suggest massive fires, high concentrations of platinum and iridium, elements rare on Earth's surface but common in asteroids and comets, and perhaps most tellingly, a form of carbon called fullerenes with extraterrestrial gases trapped inside them. This isn't the kind of evidence you can easily dismiss. These materials exist. They're found at the right depth, dating to the right time period, distributed across multiple continents. Something happened 12,800 years ago that scattered cosmic debris across much of the northern hemisphere. But here's where it gets really interesting and really controversial. If there was a cosmic impact, what did it hit? Where are the craters? The impact hypothesis researchers have an answer for this. The impacts, they suggest, occurred primarily over the North American ice sheet. A comet fragment or multiple fragments striking not solid ground but ice sheets up to 2 miles thick. The explosions would have been devastating, vaporizing billions of tons of ice instantly, triggering massive floods as meltwater surged across the landscape. But the craters themselves would have been temporary, filled in and erased as the glaciers continued to move and eventually melted completely. This would explain several mysteries: the sudden flooding evident in the geological record, the mass extinction of North American megafauna, giant mammals like mammoths, mastodons, and saber-toothed cats that had survived previous climate changes but suddenly vanished around 12,800 years ago, the widespread evidence of massive wildfires, with charcoal layers found across the continent suggesting that vast areas burned simultaneously. Most intriguingly, it would explain something that has puzzled anthropologists for over a century: the worldwide distribution of flood myths. Nearly every human culture on Earth has flood stories. The biblical account of Noah is just the most famous Western version. The Sumerians had the Epic of Gilgamesh, which predates the Bible by thousands of years and tells remarkably similar stories of a great flood destroying the world. The ancient Greeks had their version with Deucalion. Hindu texts describe massive floods in the story of Manu. Chinese mythology speaks of the great flood that transformed the landscape. Native American tribes across both continents have flood stories. So do Australian Aboriginals, Pacific Islanders, and peoples throughout Southeast Asia and Africa. Traditional archaeology has usually written this off as coincidence. Floods happen, rivers overflow, tsunamis strike coastal regions. It makes sense that many cultures would develop flood myths independently. But what if they're not independent? What if they're all dim memories of the same event, passed down through hundreds of generations? Here's what makes this idea so compelling and so disturbing. The details of these flood myths often match in ways that seem too specific to be coincidental. Many describe the flood as sudden and unexpected, coming with little warning. They frequently mention fire falling from the sky before or during the flood. They often speak of the sun being darkened, of years of cold and darkness following the catastrophe. They describe the deaths of animals and people, the destruction of previous civilizations, the survival of only a handful of individuals who had to rebuild everything from scratch. If you were an ancient human trying to describe a cosmic impact and its aftermath in mythological terms, this is pretty much exactly how you'd do it. Fire fallen from the sky, the impacts, massive floods, the melt in ice and result in deluges, darkness and cold, the climate disruption and atmospheric debris blocking sunlight, the death of animals and destruction of civilization, the mass extinction event and collapse of whatever societies existed before. Graham Hancock takes this a step further. He proposes that before the Younger Dryas catastrophe, there was an advanced civilization, not necessarily with our level of technology, but sophisticated enough to have developed agriculture, architecture, astronomy, and mathematics. This civilization, he suggests, was wiped out by the impacts, with only scattered survivors carrying fragments of their knowledge into the Stone Age. This is where mainstream archaeology draws a hard line. There's no evidence, they say, of any such civilization. No cities, no writing, no infrastructure. The archaeological record shows only hunter-gatherer societies at that period. If an advanced civilization had existed, we would have found it by now, but would we? Here's the uncomfortable question that won't go away. If a civilization existed 12,800 years ago, primarily in coastal areas that are now underwater, how much evidence would survive? The last ice age ended around 11,000 years ago. As the glaciers melted, sea levels rose by roughly 400 feet, more than 120 meters. Vast areas of coastline that were habitable during the Ice Age are now hundreds of feet beneath the ocean surface. This isn't speculation. We know that Ice Age coastlines were far more extensive than modern ones. There were large land masses connecting Britain to continental Europe, joining Alaska to Siberia, creating land bridges throughout Southeast Asia. These areas weren't frozen wastelands. Many were prime real estate, coastal zones with moderate climates and abundant resources, exactly the kind of places where humans would choose to settle. If there were sophisticated settlements in these now submerged areas, they would be extraordinarily difficult to find. Underwater archaeology is expensive, time-consuming, and technologically challenging. We've only thoroughly explored a tiny fraction of the continental shelf. Large areas remain completely unmapped at the resolution needed to spot ancient ruins, and there are hints, tantalizing suggestions that something might be down there. Sonar images of geometric formations off the coast of Cuba at depths that would require them to be over 10,000 years old. Stone structures underwater near Yonaguni in Japan that some researchers argue are too regular to be natural. Submerged settlements off the coast of India that might predate known civilizations in the region. Mainstream archaeologists remain skeptical, pointing out that unusual rock formations occur naturally and that extraordinary claims require extraordinary evidence. But the fact remains that we haven't looked very hard. Most archaeological research focuses on land, on sites we can easily access and excavate. The ocean floor remains largely unexplored. The debate between catastrophists and gradualists, between alternative historians and mainstream archaeologists, continues to rage, and it's not entirely civil. Careers have been made and lost on both sides. Hancock and researchers who support the impact hypothesis have been accused of pseudoscience, of cherry-picking evidence and ignoring data that contradicts their theories. Mainstream archaeologists have been accused of dogmatism, of refusing to consider evidence that doesn't fit their established narratives. But here's what's undeniable. Something significant happened 12,800 years ago. The climate shifted dramatically and suddenly. Megafauna went extinct across multiple continents. The black mat layer exists with its anomalous materials. Human populations experience severe disruption, with archaeological evidence showing abandonment of settlements and population declines in many regions. Whether this was caused by cosmic impacts, disrupted ocean currents, or some combination of factors remains debated. Whether there was an advanced Ice Age civilization that was destroyed is far more speculative. But the possibility that human history is more complex, more catastrophic, and more mysterious than we've assumed can't be easily dismissed. Consider this scenario. Small groups of humans, survivors of whatever catastrophe occurred, scattered across a world that had just become dramatically more hostile. Some of them carrying knowledge from before, practical skills and intellectual traditions that had been developed over thousands of years. Not high technology necessarily, but sophisticated understanding of astronomy, mathematics, architecture, agriculture. Knowledge that would seem miraculous to hunter-gatherer populations struggling to survive. These survivors couldn't rebuild what was lost. Their numbers were too small, their resources too limited, the environment too harsh. But they could preserve fragments. They could teach their children stories about the old world, pass down whatever practical knowledge might be useful. Over generations, much of this would be lost or transformed into myth. But some might survive, encoded in stories, monuments, and traditions that would puzzle archaeologists thousands of years later. This is the heart of the ancient apocalypse theory. Not that aliens built the pyramids, or that Atlantis had flying cars, but that human history has been punctuated by catastrophes severe enough to nearly reset civilization, and that we might be missing important chapters of our story because we're not looking in the right places or asking the right questions. The truth is, we don't know. We don't know if there was an advanced Ice Age civilization. We don't know exactly what caused the Younger Dryas or the Black Mat layer. We don't know why so many cultures have such similar flood myths. These are genuine mysteries, gaps in our understanding that honest scientists should acknowledge rather than dismiss. What we do know is that 12,800 years ago something happened. Something significant enough to leave traces in geology, in genetics, in the collective memory of human cultures worldwide. And in the aftermath of that something, human history took a sharp turn, setting us on the path that would lead to agriculture, civilization, and everything that came after. The survivors of whatever catastrophe occurred were tough, adaptable, and determined enough to rebuild, to take whatever knowledge they possessed and use it to create something new. They are our ancestors, as surely as the bottleneck survivors from 900,000 years ago. And their story, however incomplete our understanding of it remains, is part of what made us who we are today. But here's where things get really strange, because scattered across the ancient world, we find artifacts and texts that seem to contain knowledge that shouldn't exist. Not mystical mumbo-jumbo or vague prophecies, precise technical information, astronomical calculations and geographic details that don't match what we think ancient humans should have known. Take the Antikythera mechanism. In 1901, de Vries, exploring a Roman shipwreck off the Greek island of Antikythera, found something that would baffle scientists for over a century. A corroded lump of bronze that, when X-rayed decades later, revealed something impossible. Gears. Dozens of precisely cut bronze gears, fitted together in a complex mechanism that could calculate the positions of the sun, moon, and planets. It could predict eclipses. It tracked the Olympic Games cycle. It even accounted for the irregular orbit of the moon. This thing is from around 100 BCE. The next device we know of with this level of mechanical complexity doesn't appear until the 14th century CE. That's a 1,400-year gap. Imagine finding a laptop in medieval manuscript. That's essentially what the Antikythera mechanism represents. The ancient Greeks built an astronomical computer using technology that wouldn't be reinvented for more than a millennium. But here's what keeps scientists up at night. This mechanism shows evidence of mature technology. The gears are precisely cut. The design is sophisticated, refined. This wasn't a first attempt. This was the product of a long tradition of mechanical engineering, which means there should be predecessors, Simpler versions leading up to this masterpiece, we haven't found them. Either they're all still buried somewhere, which seems unlikely given how much Greek territory we've excavated, or they were made from materials that didn't survive. Or, and this is the disturbing possibility, the knowledge came from somewhere else, somewhere earlier, somewhere we haven't looked yet or can't look because it's buried under the sea or destroyed by time. Then there's the Piri Reis map. In 1513, a Turkish admiral named Piri Reis compiled a world map, using source materials from the Library of Alexandria and other ancient collections. Nothing unusual about that. Medieval cartographers regularly copied and updated ancient maps, but when researchers examined the Piri Reis map in the 1960s, they noticed something extraordinary. The southern portion of the map shows the coast of Antarctica, not the ice-covered Antarctica we know today, a coastline, mountains, river valleys, details that match the actual topography of Antarctica beneath the ice. Topography we only discovered ourselves using ground-penetrating radar in 1949. Antarctica was officially discovered in 1820. Its coastline has been covered by ice for at least 6,000 years, maybe longer. So how did a medieval map, supposedly based on ancient sources, show accurate details of Antarctic geography that was hidden under miles of ice? The standard explanation is that the mapmaker was just guessing, or the similarities are coincidental, or modern researchers are seeing patterns that aren't really there. Maybe, but the level of detail is unsettling. Bays and inlets that actually exist, mountain ranges in approximately correct positions. It's either an incredible coincidence or Piri Reis was copying sources that came from a time when Antarctica's coast was visible, which would mean someone was exploring and mapping Antarctica before 4000 BCE, before the supposed invention of writing, before the first civilizations we know about even existed. And who were these pre-civilization cartographers? Where did they live? What happened to them? Now, let's talk about the Sumerian king list. This ancient text, carved in cuneiform around 2100 BCE, lists all the rulers of Sumer going back to the beginning. Like many ancient king lists, it's partly historical and partly mythological. The later kings have reasonable reign lengths, 20, 30, maybe 40 years. We can verify some of them from other sources, but the earlier you go, the weirder it gets. The list mentions kings who reigned for 43,200 years. One guy supposedly ruled for 36,000 years. And before the Great Flood, which the Sumerians describe in detail, there were kings who collectively ruled for 241,200 years. These numbers are absurd, obviously. No human lives that long, so scholars assume these are mythological figures, legendary ancestors, not real people. But here's the thing. The Sumerians were meticulous record keepers. They documented everything: grain deliveries, legal disputes, religious festivals. They weren't prone to wild exaggeration in their bureaucratic documents. So why suddenly insert fantasy numbers into an official king list? One theory is that these aren't individuals, they're dynasties. Long periods of rule compressed into single names. The 43,200 years might represent 43,200 months, which would be more reasonable. But even adjusted, we're talking about an incredibly long prehistoric period, and the list makes a clear distinction. Before the flood, one set of rulers. After the flood, a completely different line. The flood divides history. Something happened. Something catastrophic enough to end one era of human civilization and begin another. Sound familiar? But the real bombshell came from genetics. In 2010, scientists sequenced DNA from a finger bone found in Denisova Cave in Siberia. They were expecting Neanderthal DNA. Instead, they found something else. a third species of human, genetically distinct from both modern humans and Neanderthals. They called them Denisovans, and for a while, that single finger bone was the only physical evidence we had that they existed. But their DNA told a different story. Denisovans interbred with modern humans extensively. Modern Melanesians carry about 5% Denisovan DNA. Indigenous Australians have it. So do people across Southeast Asia and the Pacific. That finger bone represents a species that lived alongside us, shared territories with us, had children with us. An entire branch of humanity that we only discovered in 2010 because we finally developed the technology to read ancient DNA. And here's what makes this terrifying. If we only just discovered Denisovans, who else haven't we found? How many other human species existed during that gap period between behavioral modernity and the rise of civilization? The genetic evidence suggests there were at least 3 major interbreeding events between different human populations, maybe more. Small groups of advanced hominids, each with their own cultural traditions, technologies and knowledge, meeting, mixing, sometimes cooperating, sometimes competing. What did they know? What could they do? Some Denisovan populations adapted to high altitudes, developing genetic variants for processing oxygen that still help modern Tibetans survive. At extreme elevations, others seem to have been sophisticated seafarers, reaching islands that required advanced navigation. They had culture, they had technology, they had knowledge, and then most of them disappeared. Not all at once, not from a single catastrophe. But gradually, over thousands of years, the genetic signal fades, absorbed into the modern human population or dying out in isolated pockets. All that's left are those fragments of DNA, floating through modern genomes like messages from ghosts. Which brings us back to those ancient texts, because once you accept that there were multiple human species, some of them quite advanced, living during the gap period, suddenly those impossible knowledge claims start looking different. That astronomical precision in ancient texts, maybe they didn't figure it out from scratch. Maybe they inherited fragments of knowledge from earlier cultures, earlier species even. Ancient Babylonian astronomers could predict lunar eclipses with remarkable accuracy. They knew the length of the solar year to within minutes. They tracked the movements of planets across decades, calculating cycles that wouldn't be matched until the Renaissance. How? They claim their knowledge came from texts passed down from before the flood, from the Apkallu, mythical sages who taught humanity the arts of civilization. The ancient Egyptians aligned the Great Pyramid to true north with an accuracy of 3/60th of a single degree. They did this supposedly using only copper tools and rope. The pyramid's proportions encode mathematical constants like pi and phi. Its internal chambers align with specific stars. The sophistication required is staggering, and the Egyptians themselves claim they didn't invent this knowledge. They said it came from the time of Zep Tepi, the first time, an ancient golden age when gods walked among men. In ancient India, the Vedic texts describe astronomical events, precession of the equinoxes, details of planetary motion, even concepts that sound remarkably like atomic theory. The Mahabharata describes weapons that sound disturbingly similar to modern weapons of mass destruction. Mainstream scholars say these are poetic descriptions, metaphors, not literal events. But what if some of them are descriptions of real technologies, real events, filtered through millennia of oral tradition? What if ancient humans encountered things, other species, other civilizations that they didn't fully understand? They would describe what they saw using the vocabulary they had. Advanced technology becomes magic. Other human species become gods or demons. Catastrophic events become divine punishment. The pattern repeats across cultures. Flood myths in Mesopotamia, Greece, India, China, the Americas. Stories of an earlier age when humans lived longer, were taller, were more advanced. Then catastrophe. Flood, fire, darkness. The old world ends. The new world begins. We've always assumed these are just myths, cultural memories of the localized disasters blown out of proportion. But what if they're fragments of actual history, distorted by time, mixed with mythology, but containing kernels of truth about real events during that gap period? Consider this. We know from the genetic bottleneck research that human populations crashed dramatically around 900,000 years ago. We know multiple human species coexisted and interbred for hundreds of thousands of years. We know behavioral modernity appeared suddenly around 70,000 years ago, then seemingly vanished for 40,000 years before reappearing. We know sea levels have risen dramatically since the last ice age, drowning coastlines where most ancient humans would have lived. How much knowledge was lost? How many times did human cultures rise to significant levels of sophistication only to be destroyed by climate change, disease, warfare, or simple demographic collapse? And how much of that lost knowledge survived in fragments, copied from text to text, passed down through oral traditions, preserved in myths and legends that we dismiss as primitive superstition? The Antikythera mechanism proves ancient humans could build sophisticated technology. The genetic evidence proves multiple human species coexisted and exchanged knowledge. The archaeological evidence proves humans were behaviorally modern far earlier than we thought. And the texts, those strange, impossible texts, they keep insisting something came before, something we've forgotten. Maybe they're right. Here's something that should keep you up at night. Modern humans, anatomically identical to us, have existed for at least 200,000 years, maybe 300,000, depending on which fossils and which definitions you accept. That's not controversial. The bones don't lie. We've got skulls from Ethiopia, Morocco, South Africa, all showing the same basic features we see in modern humans today. High foreheads, small faces, prominent chins. These weren't some intermediate form. These were us. So here's the puzzle. Take two humans, give them 200,000 years, and do the math. Human populations can double every 25 years under decent conditions. That's not an optimistic estimate, that's just basic demography. Even accounting for high infant mortality, short lifespans, and periodic disasters, human populations should grow exponentially when they have room to expand and resources to exploit. Start with just 10,000 people, 200,000 years ago. Give them conservative growth rates, account for periodic die-offs, and by 50,000 years ago, there should have been hundreds of millions of humans on this planet. By 20,000 years ago, we should have filled every habitable corner of the Earth. The math is simple. The numbers don't lie. Except they do. Because when we look at the actual genetic evidence, we find something completely different. Something that makes absolutely no sense. For most of human prehistory, the global population remained shockingly, impossibly small. We're not talking about millions. We're not even talking about hundreds of thousands. Genetic studies suggest that for vast stretches of time, the effective breeding population of humans might have been as low as 10,000 to 15,000 individuals. That's not the total population. That's the number of people actually reproducing and passing on genes. The total population might have been higher, maybe 50,000 to 100,000, but that's still nothing. That's barely enough to fill a modern football stadium, and it stayed that way. For thousands upon thousands of generations, human populations remained locked at these incredibly low numbers. The genetic diversity we see in modern humans, the number of different variants of each gene, the patterns of mutations across populations, all of it points to the same conclusion. We spent most of our history as an endangered species, hanging on by our fingernails, never quite managing to achieve the population explosion that should have been inevitable. Think about what this means. These weren't stupid people. They had brains identical to ours, bodies identical to ours, the same capacity for innovation and cooperation that eventually let humans dominate the planet. They could make sophisticated tools, hunt large animals, build shelters, create art. They survived in environments from African savannas to European forests. They were clearly successful at basic survival. So why didn't they multiply? Why did it take 150,000 years for anatomically modern humans to do what we've done in the last 10,000? Fill the Earth, build civilizations, transform every ecosystem we encountered. The conventional answer is simple. They were limited by resources and technology. Hunter-gatherer populations naturally stay small because they need huge territories to support themselves. You can't have population explosions when each person needs several square miles of productive land to gather enough food. Move into a new territory, fill it to its carrying capacity, then stop growing. Population stability through resource limitation. But here's where that explanation starts to break down. The genetic evidence doesn't show steady, stable populations maintaining equilibrium with their environments. It shows something much more violent. Multiple severe population crashes, bottlenecks where human numbers dropped so low that most genetic diversity was simply eliminated. Events so catastrophic that only a tiny fraction of the human population survived to reproduce. We can see these bottlenecks in our DNA. When a population crashes, it leaves a signature: reduced genetic diversity, long stretches of chromosome where everyone has similar or identical sequences, patterns that can only be explained by a dramatic reduction in the number of breeding individuals. And human DNA is full of these signatures. Not just one bottleneck, but multiple events scattered throughout our prehistory. The most severe appears to have happened somewhere between 50,000 and 100,000 years ago. Genetic modelling suggests the entire human population might have crashed to fewer than 10,000 individuals, maybe as few as 2,000. For perspective, that's smaller than many individual gorilla populations today. We were more endangered than mountain gorillas, more vulnerable than giant pandas. One bad decade, one regional disaster, and we could have disappeared entirely. What could cause something like that? The honest answer is we don't know for certain, but we have clues. Climate records from ice cores and ocean sediments show that this period was marked by dramatic instability. The Earth was transitioning into the last ice age, and the transition wasn't smooth. There were periods of rapid cooling, where global temperatures dropped 10 or 15 degrees Celsius in just a few decades. Regions that had been temperate forests became frozen tundra. Coastlines that had supported human populations were buried under massive ice sheets. Rainfall patterns shifted, turning once reliable water sources into seasonal streams or dry wadis. For hunter-gatherers depending on specific ecosystems, these changes would have been catastrophic. The animals they hunted would have migrated or died out. The plants they gathered would have failed. Fresh water would have become scarce or contaminated, and it wouldn't have happened slowly enough to adapt. These were rapid onset disasters, climate shifts that could transform an entire landscape within a single human lifetime. Then there's disease. We usually think of epidemic diseases as something that only affects large, dense agricultural populations, and it's true that many of the worst plagues in history required cities to spread. But other diseases can devastate small populations just as effectively. A single infected traveller carrying smallpox or measles into an isolated band of humans could kill every child in the group. A contaminated water source could wipe out an entire community through dysentery or cholera. And unlike modern populations with some genetic resistance to common diseases, these early humans would have been immunologically naive, lacking any inherited defences. Volcanic eruptions could have done it too. We know from historical records what a single major eruption can do to climate. The eruption of Mount Tambora in 1815 caused the year without a summer, global cooling that led to crop failures and famines across Europe and North America. Now imagine something 10 times worse. The Toba supervolcano in Indonesia erupted about 74,000 years ago, the largest volcanic event in the last 2 million years. It ejected thousands of cubic kilometers of ash and sulfur dioxide into the atmosphere, blocking sunlight and causing a volcanic winter that might have lasted years or even decades. Some researchers think Toba caused the bottleneck we see in human genetics. The climate disruption would have killed off most large animals, destroyed vegetation, made survival nearly impossible except in a few tropical refuges. Humans elsewhere would have simply died, starved, or frozen, or both. Only small populations in protected areas, places with reliable water and resilient ecosystems, would have survived. But here's what's really disturbing. Toba might not have been the only bottleneck. The genetic evidence suggests multiple crashes, multiple periods where human populations dropped to dangerously low levels, which means whatever nearly killed us once happened again, and again, and possibly again. This creates what scientists call the resilience paradox. How does a species survive multiple near-extinction events? Most species that get reduced to a few thousand individuals don't recover. They go extinct, finished off by the next disaster, or simply by accumulated genetic problems from inbreeding. The fact that humans survived suggests we had something special, some combination of intelligence, adaptability, and sheer stubborn refusal to die that let us claw our way back from the edge repeatedly. But there's another implication, one that's even more unsettling. Every time human populations crashed, we lost things: knowledge, technologies, social structures. The survivors would have been focused entirely on immediate survival, not on preserving cultural information. Complex skills that took generations to develop, sophisticated technologies that required specialized knowledge, social institutions that depended on large groups, all of it could have been lost. And then when populations recovered, humans would have had to reinvent everything. Start over from basics, rediscover technologies that earlier populations had mastered. This could explain the pattern we see in the archaeological record. Long periods of apparent stasis, where human technology seems stuck at a certain level for thousands of years, then sudden bursts of innovation. Maybe those weren't periods of stasis at all. Maybe they were periods of recovery, humans slowly rebuilding what had been lost in the last catastrophe. Think about what this means for the time gap. Those missing 190,000 years when anatomically modern humans existed, but apparently didn't accomplish anything remarkable. Maybe they did accomplish remarkable things. Maybe they built sophisticated cultures, developed impressive technologies, created knowledge systems that would astound us. And maybe all of it was destroyed, not once but multiple times by climate disasters and disease outbreaks and volcanic winters that nearly ended our species. We'd never know. because the survivors wouldn't have left elaborate monuments or written records. They'd have left stone tools and temporary shelters and small populations scattered across harsh landscapes, clinging to survival, which is exactly what we find in the archaeological record. The population puzzle suggests something profound about human history. We're not looking at a species that slowly, steadily progressed from primitive beginnings to modern civilization. We're looking at a species that repeatedly came within a hair's breadth of extinction. A species that lost and rebuilt its accumulated knowledge multiple times. A species that had to learn, again and again, how to survive when everything was trying to kill them. And every time somehow they made it through. Small groups in scattered refuges, maintaining enough genetic diversity to eventually repopulate the world, preserving enough knowledge to rebuild. Until finally, in the last 10,000 years, conditions stabilized enough for human populations to explode, for civilizations to develop, for knowledge to accumulate faster than it could be destroyed. But those earlier populations, the ones who survived the bottlenecks, who rebuilt after catastrophes we can barely imagine, they're still with us. We carry their genes, the ones selected for survival under the most extreme conditions. We carry their resilience, their adaptability, their refusal to quit even when extinction seemed certain. We're all descendants of the survivors, all products of repeated near extinctions, all evidence that sometimes a species can be pushed to the very edge and still find a way back. But that raises an even bigger question. If humans almost went extinct multiple times, if we lost and rebuilt our knowledge repeatedly, what else might have been lost? What technologies, what knowledge, what achievements disappeared without a trace in those ancient catastrophes, and how would we ever know? Now here's where things get really strange. Because while we're trying to figure out what our ancestors were doing during those missing millennia, we keep stumbling across artifacts and structures that shouldn't exist according to our current timeline of human development. Technologies that appear thousands of years before they're supposed to. Capabilities that seem impossible given the tools available. Let's start with something simple. Stones. Except there's nothing simple about what ancient peoples did with stones. In Peru, high in the Andes at an altitude that makes breathing difficult for modern visitors, there's a place called Sacsayhuaman. It's a complex of walls built from massive limestone blocks, some weighing more than 200 tons. That's about the weight of 2 fully loaded Boeing 737s per stone. But the weight isn't the weird part. The weird part is how they fit together. These stones are cut and placed with such precision that you literally cannot slide a knife blade between them. No mortar, no cement, just stone against stone fitted so perfectly that after 500 years of earthquakes, harsh weather, and the passage of time, they remain locked together as tightly as the day they were placed. Modern engineers have tried to replicate this. They've used laser measuring equipment, computer-controlled cutting tools, hydraulic lifts, everything available to 21st century technology, and they can't match it. The best they can do is pretty close, but not quite there. The margins are always slightly off. The fit is never quite as perfect. So how did people without metal tools, without wheels, without computers or lasers or any kind of modern measuring equipment achieve precision that we struggle to replicate today? The standard archaeological answer is time and patience. Lots of workers, generations of accumulated knowledge, careful grinding and shaping using stone tools and abrasives, and maybe that's right. Maybe that's all it took. But then you look closer at some of these stones and things get weirder. Many of them aren't just rectangular blocks. They have complex, irregular shapes, like three-dimensional jigsaw puzzle pieces. Some have interlocking protrusions and corresponding indentations. Others feature multiple angles and compound curves. Every surface is precisely cut to match the adjacent stone perfectly. This isn't just moving and stacking rectangular blocks, which would be impressive enough. This is creating custom-fitted polygonal stones, each one unique, each one designed to lock with specific neighbours. The level of planning required is staggering. You can't just cut one stone and then cut the next one to match. You need to plan the entire wall section in advance, understand how every stone will interact with every other stone, and then execute that plan with millimetre-level precision. And we're supposed to believe they did this by grinding away with hand tools for really long periods? The thing is, there's no archaeological evidence of the intermediate steps, no practice walls with imperfect fits, no piles of rejected stones that didn't quite work out, no evolution from simple rectangular blocks to complex polygonal construction. These techniques just appear in the archaeological record, fully developed. It's like someone skipped straight from basic addition to calculus without showing their work. The pattern repeats across the ancient world. In Egypt, there's an unfinished obelisk in an Aswan quarry. It's enormous, would have weighed about 1,200 tons when completed. But what's fascinating isn't its size, it's the evidence of how it was being cut from the bedrock. All around the obelisk you can see trenches carved into the granite, not chipped or smashed, but carved. Smooth, regular grooves showing systematic removal of one of the hardest stones known to man. The official explanation is that workers used dolerite pounders, extremely hard stones used to repeatedly strike the granite until it fractured and could be removed. But engineers who've studied the site point out problems with this explanation. The grooves are too regular, the sides too smooth. Pounding granite with stone hammers creates irregular surfaces, fracture patterns, stress marks. These grooves look more like they were cut with some kind of saw or grinding tool. And then there's the speed issue. Experimental archaeology has shown that using dolerite pounders to remove granite is incredibly slow. Based on modern attempts to replicate the technique, completing the unfinished obelisk would have taken hundreds of workers several decades of constant labour. Maybe that's what happened. But it raises questions about why we don't find evidence of this massive multi-generational quarrying operation. Where are the millions of dolerite pounders that would have been worn out in the process? Where are the workers' camps, the tools, the infrastructure needed to support hundreds of people for decades? Some researchers have proposed that ancient Egyptians had access to some kind of advanced cutting technology we don't understand yet. Maybe sophisticated bronze saws with abrasive compounds. Maybe some kind of chemical process that weakened the stone. Maybe techniques using sound or vibration to fracture granite along specific lines. These sound like fringe theories, and most mainstream archaeologists dismiss them. But they're proposed by people with engineering backgrounds who understand materials and manufacturing. They're not saying aliens helped. They're saying maybe ancient peoples figured out technologies we haven't rediscovered yet. And there's more evidence that supports this possibility. Take drilling. Ancient sites all over the world show evidence of precision drilling into hard stone. Not just little holes, but deep core drilling. Sometimes several feet into granite or basalt. In Egypt, there are granite blocks with drill holes that show what engineers call a spiral pattern, evidence of a drill bit advancing through the stone at a consistent rate. Modern experiments trying to replicate these drill holes using copper tools and abrasives have struggled. The ancient holes show faster penetration rates than should be possible with the tools we think they had available. Some drill cores show penetration rates of 1 inch per revolution. Using copper and sand, modern attempts achieve maybe 1 inch per 50 revolutions. That's not a small discrepancy. That's a difference of 50 times. Either ancient peoples were using techniques vastly more efficient than anything we've tried, or they had access to tools we don't know about. And then there's the acoustic weirdness. Multiple ancient sites display sophisticated acoustic properties that seem deliberately engineered. At Gobekli Tepe, which we discussed earlier, archaeologists have discovered that the T-shaped pillars are positioned to create specific resonance patterns. Sounds produced in certain locations echo and amplify in precise ways. In Malta, the hypogeum of Halsaflieni, an underground temple complex carved from solid limestone, features what researchers call an oracle room. When someone speaks in a specific frequency range, around 110 Hz, the entire chamber resonates. The sound doesn't just echo, it creates a physical vibration you can feel in your chest and bones. Testing has shown this wasn't accidental. The room's dimensions, shape, and surface texture all contribute to amplifying this specific frequency while dampening others. Someone designed this deliberately. Someone understood acoustics well enough to engineer a space that would produce specific sound effects when human voices reached certain pitches. In ancient Greece, the theatre of Epidaurus is famous for its perfect acoustics. A coin dropped in the centre of the orchestra can be heard clearly in the back row, 55 metres away and 23 metres above. Modern acoustic engineers have analysed the structure and found that the limestone seats and their geometric arrangement create a natural acoustic filter that enhances speech frequencies while suppressing background noise. Could ancient builders have discovered these principles through trial and error? Maybe. But that implies a level of systematic experimentation and knowledge accumulation that we don't usually associate with ancient cultures. You don't stumble onto perfect acoustic design by accident. You get there through understanding of sound waves, reflection patterns, resonance frequencies, mathematical principles that we think weren't formalized until thousands of years later. Perhaps the most disturbing evidence of advanced ancient capabilities comes from medicine, specifically brain surgery. Trepanation, the practice of drilling or scraping holes into the human skull, is found in prehistoric sites worldwide, not as ritual sacrifice or torture, but as actual medical procedures. We know this because the skulls show evidence of healing. The bone around the holes shows signs of regrowth, proving these people survived the surgery and lived for months or years afterward. Some individuals underwent multiple trepanations, several holes in the same skull, all showing signs of healing. They had their skulls opened repeatedly and survived each time. The survival rates are shocking. Analysis of prehistoric trepanned skulls suggests survival rates between 50% and 90%, depending on the time period and location. For comparison, survival rates for similar procedures in the American Civil War in the 1860s were around 50%. During World War I, they reached about 70%. How were Stone Age surgeons achieving survival rates comparable to 19th and early 20th century medicine? They didn't have antibiotics. They didn't have anesthesia beyond whatever plants might provide pain relief. They didn't have sterilization techniques or blood transfusions, or any of the medical infrastructure we consider essential for invasive surgery. Yet they were drilling into people's skulls, and those people were surviving. Not occasionally, but routinely. This implies knowledge of anatomy, understanding of infection control, pain management techniques, and surgical procedures that we can barely explain. The skulls show clean cuts, precise holes, careful technique. These weren't desperate emergency procedures performed by panicked amateurs. These were systematic operations performed by specialists who knew exactly what they were doing, and again there's no evidence of the learning curve, no piles of unsuccessful attempts. The earliest trepanations show the same level of skill as later ones. The technique appears fully developed from the start. This pattern, advanced capabilities appearing without antecedents, repeats constantly in the archaeological record. Technologies that should have taken centuries to develop showing up complete. Knowledge that should have required generations of accumulated learning appearing suddenly. Mainstream archaeology explains this through knowledge loss and sampling bias. Maybe the intermediate steps existed but haven't been found yet. Maybe they were made from perishable materials that didn't survive. Maybe they happened in regions we haven't excavated yet. These are reasonable arguments. The archaeological record is incomplete. We've only excavated a tiny fraction of potential sites. Absence of evidence isn't evidence of absence. But there's another possibility that makes some researchers uncomfortable. Maybe there were periods of advanced development that we've completely missed. Not alien intervention or Atlantean superscience, but human cultures that reached relatively high levels of technical capability, then collapsed and lost that knowledge before it could spread widely. We know this happens. The Roman Empire had concrete, plumbing and engineering capabilities that Europe didn't recover for over 1,000 years after Rome fell. Medieval Europeans looked at Roman aqueducts and amphitheatres and had no idea how to replicate them. The technology had existed, then vanished, then had to be slowly redeveloped. If a collapse that happened in recorded history could cause that much knowledge loss, what about collapses that happened in prehistory? What about the technological achievements of cultures that existed during those missing millennia we discussed earlier? Maybe some prehistoric cultures developed sophisticated technologies, used them for centuries or even millennia, then collapsed when climate changed or resources depleted or diseases spread. Their technologies, known only to small groups of specialists, died with them. Later peoples rebuilt but had to start over, rediscovering capabilities their ancestors had mastered and lost. This would explain the sudden appearances, not because the technology was alien or magical, but because it had existed before, been lost, and was being rediscovered. The same solutions emerging independently because they're the logical answers to universal problems. It would also explain why some ancient capabilities seem impossibly advanced. They're not impossible. They're just the result of focused development over long periods that we're not accounting for in our historical models. Generations of ancient engineers and craftspeople solving specific problems with the same systematic approach that modern engineers use, accumulating knowledge and refining techniques until they achieved results that look miraculous to us because we don't have the full context. But here's what keeps researchers up at night. We can speculate about lost knowledge and rediscovered techniques. We can propose explanations for how ancient peoples might have achieved these remarkable feats. But the truth is, we don't actually know. We can't replicate many of these ancient technologies using the tools we think they had available. We can't explain how they achieved precision that challenges modern capabilities. We can't account for medical procedures that shouldn't have been survivable. We have theories, we have educated guesses, but we don't have proof. And that gap between what ancient peoples accomplished and what we think they should have been capable of keeps getting wider the more we investigate. Every year brings new discoveries that push the boundaries of what we thought was possible for prehistoric and ancient cultures. Every year brings new evidence that maybe we've been dramatically underestimating the capabilities of our ancestors. The standard narrative of human progress describes a steady upward trajectory. Stone Age giving way to Bronze Age, giving way to Iron Age, each period clearly more advanced than the last. Simple tools replaced by complex ones. Basic knowledge expanded into sophisticated understanding. But the evidence increasingly suggests progress wasn't that linear, that human history might be more complicated, with periods of advancement followed by collapse and knowledge loss, with different cultures independently developing sophisticated technologies that later vanished. With capabilities appearing, disappearing, and reappearing across thousands of years. We're not talking about ancient aliens or mystical lost continents. We're talking about the possibility that human technological development has been far more complex and non-linear than our current models assume. That prehistoric and ancient peoples were far more capable than we give them credit for. That they solved problems in ways we still don't fully understand, and until we can actually replicate what they accomplished using the tools we think they had, until we can explain every drill hole and every precision-cut stone and every successful brain surgery, we have to admit something uncomfortable. There are things our ancestors knew that we've forgotten, techniques they mastered that we can't duplicate, capabilities they possessed that we're still trying to understand. The technologies exist. We can see them, measure them, study them. But how they were created remains in many cases a mystery, and that mystery is a challenge, not just to our understanding of ancient history, but to our assumptions about human capability itself. Here's something that might surprise you. If you ask most mainstream archaeologists about the prehistoric time gap, they won't dismiss the mystery. They won't tell you we have all the answers. What they'll actually say is more unsettling. They'll tell you that the archaeological record is fundamentally, irreparably incomplete, that we're working with fragments of fragments, that everything we know about human prehistory is based on the tiniest sliver of evidence, and that whole civilizations could have risen and fallen without leaving a single trace we could find. This isn't conspiracy theory. This is the honest assessment from the people who've spent their lives digging through humanity's past. Because here's the thing about archaeology. It's biased. Not in a political way, but in a fundamental, unavoidable way. The archaeological record preserves certain materials and erases others. It favours stone and pottery, materials that can survive tens of thousands of years buried in the ground. It destroys wood, textiles, leather, plant materials, anything organic. And that's a problem, because for most of human history, most of what humans made was organic. Think about what this means. Imagine you're trying to reconstruct modern civilization thousands of years from now, but the only evidence you have is what survived being buried underground for millennia. You'd find concrete foundations, maybe some glass and ceramic, definitely a lot of plastic, which is going to confuse future archaeologists endlessly. But you'd miss almost everything that makes our world recognizable. No books, no computers, no clothing, no wooden furniture, no evidence of most of our technology, our art, our daily lives. That's the situation we're in when we look at prehistory. We're not just missing details, we're missing entire categories of human achievement. Take wooden structures. Wood is one of humanity's oldest and most versatile building materials. It's strong, relatively easy to work, and available almost everywhere humans lived. Archaeological evidence shows humans were using sophisticated woodworking techniques at least 400,000 years ago. But wood rots. In most environments, wooden structures disappear completely within decades or centuries. The exceptions are rare. Waterlogged environments where oxygen can't reach the wood. Desert conditions so dry that decay bacteria can't survive. Frozen environments like glaciers or permafrost. This means we have virtually no evidence of wooden architecture from most of human prehistory. and wooden architecture could have been sophisticated, complex, beautiful. We know from recent history that cultures can create extraordinary wooden buildings without using any stone. Japan's wooden temples, Scandinavia's stave churches, the Pacific Northwest longhouses, all of these traditions involve advanced engineering, precise joinery, elaborate decoration. Now imagine similar traditions existing 20,000 years ago, 50,000 years ago, 100,000 years ago. They would have vanished completely, leaving nothing we could find. The people who built them would appear in our archaeological record as simple hunter-gatherers, because wood doesn't preserve and we'd never know what they were capable of creating. The same goes for textiles. Fabric almost never survives more than a few thousand years. We have tiny fragments from especially favourable preservation conditions, but that's it. Yet textile production can be incredibly sophisticated. It requires abstract thinking, mathematics, complex hand-eye coordination. Some researchers think weaving might have been as important to human cognitive development as tool-making. But we have almost no direct evidence of prehistoric textiles. We can only infer they existed from things like bone needles and spindle whorls. What if prehistoric peoples developed elaborate textile traditions, complex patterns, sophisticated dyeing techniques, specialized fabrics for different purposes? We'd never know. It would all be gone. Leather, basketry, cordage, wooden tools, plant-based medicines, all of it gone. And these weren't peripheral aspects of prehistoric life. These were probably central technologies, the things people used every day. We're like someone trying to understand a painting by looking only at the frame. But the problem goes deeper than preservation bias. There's also the sampling problem. And this is where things get really humbling. Archaeologists estimate that we've excavated less than 1% of potential archaeological sites worldwide. Probably much less, maybe 0.1%. Think about that. We're reconstructing all of human prehistory from less than 1% of the available evidence. Why so little? Resources. Archaeological excavation is expensive, time-consuming, and requires specialized expertise. Most countries don't have the funding to excavate more than a handful of sites. Permission issues. You can't just dig anywhere. You need permits, cooperation from local communities, agreements with property owners, priorities. Archaeology often competes for funding with more immediately pressing concerns like infrastructure, education, healthcare. And here's the kicker. We don't even know where most sites are. Archaeological sites don't announce themselves. They're buried, overgrown, submerged, or covered by modern development. We find them through luck, accident, or expensive survey techniques that can only be applied to limited areas. This means entire regions remain archaeologically unknown. Vast stretches of Africa, Asia, and South America have never been systematically surveyed. Not because archaeologists aren't interested, but because the resources don't exist to do the work. What might be hiding in those unexplored regions? We have no idea. That's the point. Then there's the climate data. And this is where the story gets really wild, because the more we learn about climate history, the more we realize how unstable Earth's climate has been during human evolution. We used to think climate changed slowly, gradually, predictably. Now we know that's wrong. Climate can shift dramatically in decades, sometimes in years. Ice core data from Greenland shows temperature swings of 10 to 15 degrees Celsius happening in as little as a decade during the last ice age. Ocean circulation patterns that collapsed within a human lifetime. monsoon systems that shifted position over just a few generations. What would this do to human populations? It would devastate them. Societies adapted to one climate regime would suddenly find their territories uninhabitable. Resources they depended on would disappear. Technologies optimized for one environment would become useless. Any progress toward complexity, any movement toward civilization, could be wiped out overnight by climate change. And this didn't happen once. It happened repeatedly, over and over throughout the period we're trying to understand. So maybe there were sophisticated societies during the prehistoric time gap. Maybe humans developed complex technologies, built impressive structures, created elaborate cultures, and maybe rapid climate changes destroyed them, scattered the survivors, reset human development to square one, not once, but many times. The evidence would be gone, swallowed by rising seas, buried under glacial deposits, scattered by migrating populations desperate to survive. We'd never find it because we'd never know where to look. But sometimes we do find things, and when we do, our entire understanding can change overnight. This happens more often than you might think. Gobekli Tepe was discovered in 1994. Before that, we thought monumental architecture was impossible before agriculture. The site proved us wrong in a single season of excavation. Everything we thought we knew about the Neolithic Revolution had to be reconsidered. Denisovans were discovered in 2010. A single finger bone from a cave in Siberia revealed an entire previously unknown human species, one that had interbred with modern humans and left genetic traces in populations across Asia and Oceania. Homo naledi was discovered in 2013. Another human species, this one possibly using fire and creating symbolic art despite having a brain 1/3 the size of ours. That discovery is still reshaping our understanding of human cognitive evolution. Each of these discoveries was unexpected. Each one forced a major revision of human prehistory, and each one happened within the last 30 years. The pace of discovery is accelerating, and each new find suggests how much we still don't know. Now we have technologies that are revolutionizing archaeology. LiDAR, light detection and ranging, uses laser pulses from aircraft to create detailed topographic maps that can see through forest canopy. This technology has revealed thousands of previously unknown structures in the past decade alone. In Central America, LiDAR surveys have discovered entire Maya cities that were completely hidden by jungle, networks of roads, extensive agricultural systems, defensive fortifications, structures that had been walked past by archaeologists for a century without being recognized. In Cambodia, LiDAR revealed that Angkor Wat wasn't an isolated temple complex, but the center of a vast urban landscape covering over 400 square miles. An entire medieval city that we never knew existed. Ground-penetrating radar, satellite imagery, drone surveys. All of these technologies are showing us sites we never suspected were there, and we've only just begun applying them. Most of the world hasn't been surveyed with these tools yet. What else is out there? What other cities are hiding under jungle canopy, beneath desert sands, under modern development? We genuinely don't know. But every few months someone announces a new discovery that was invisible until we looked with the right technology. Then there are the underwater sites. Sea levels during the last ice age were 400 feet lower than today. This means vast stretches of what was once prime human territory, coastal areas with abundant resources, are now underwater, and we've barely begun to explore these submerged landscapes. Every time marine archaeologists survey prehistoric coastlines, they find evidence of human activity. Stone tools, hearths, structural remains. But systematic underwater archaeology is even more expensive and difficult than land archaeology. We've explored maybe a fraction of 1% of these drowned sites. What's down there? Settlements, trade centres, specialised coastal societies that were completely erased when the seas rose? We'll probably never know unless we develop much cheaper ways to explore underwater sites. The honest truth is this: we're doing our best with massively incomplete data. We're making educated guesses based on fragments. We're extrapolating from the tiny portion of the record that happened to survive and that we happen to find. Most archaeologists will tell you this openly. They'll explain that every conclusion comes with caveats, that new evidence could overturn current theories, that we're aware of how much we don't know. The prehistoric time gap might never be fully explained. The evidence might simply be gone, destroyed by time, climate, geological processes. But the gap is shrinking. Every year brings new discoveries. Every decade brings new technologies that let us see what was previously invisible. We know more now than we did 10 years ago. We'll know more in 10 years than we do now. The picture is coming into focus slowly, piece by piece, discovery by discovery. But here's what makes this exciting rather than frustrating. Every gap in our knowledge is an opportunity. Every unanswered question is an invitation to look closer, dig deeper, think more creatively about what the evidence might mean. The prehistoric time gap isn't just a mystery, it's a frontier. And like all frontiers, it's full of possibilities. Some of them will turn out to be true, others will prove to be illusions. But we won't know which is which until we keep exploring, keep questioning, keep being willing to revise our understanding when new evidence appears. That's not a weakness of science. That's its greatest strength. The willingness to say we don't know and then go find out. So here we are, at the end of our journey through the greatest mystery in human history. And if you're feeling a bit unsettled, a bit uncertain about what you thought you knew, good. Because that's exactly where the evidence leaves us. Let's recap what we've discovered. Anatomically modern humans, people who looked exactly like us, with brains just as large and complex as ours, existed for somewhere between 200,000 and 300,000 years before anything we'd recognize as civilization appeared. That's not a gap of a few centuries or even a few millennia. That's longer than the entire span of recorded history, multiplied by 100. For most of that time, these humans, our direct ancestors, left almost no trace beyond stone tools and occasional bones. No cities, no monuments, no agriculture, no writing. Just small groups moving through landscapes we can barely imagine, surviving in ways we're still trying to understand. Then, seemingly suddenly, around 12,000 years ago, everything changed. Agriculture, settlements, art, architecture, complex societies, as if someone had flipped a switch and humanity collectively decided to become civilized all at once. But we've seen the cracks in that neat narrative. Gobekli Tepe, built by hunter-gatherers who supposedly didn't have the social organization for such projects. Underwater structures off coasts around the world, hinting at civilizations that vanished beneath rising seas. Ancient knowledge encoded in myths and texts, knowledge that seems impossible for the people who supposedly created it. Technologies that appear thousands of years before they should. Genetic evidence of population bottlenecks and mass die-offs that nearly ended our species before it really began. Every one of these discoveries challenges what we thought we knew. Every one forces us to push back the timeline of human sophistication just a little bit further. And here's the humbling truth. We may never know the full story. The evidence is too fragmentary, too scattered, too erased by time and climate, and the simple fact that most of what humans created doesn't survive long enough to fossilize. Think about it. If our current civilization collapsed tomorrow, what would remain after 100,000 years? After ice ages and sea level changes and continental drift? Maybe a few stone structures, some pottery shards, possibly traces of nuclear waste in geological strata. That's about it. Everything else, all our books and computers and monuments and art would be gone. Future archaeologists would probably conclude we were just another species of primitive humans, barely different from our predecessors. So when we look back at those blank millennia in our past, we have to ask ourselves, how much are we missing? How many rises and falls of complex societies have been completely erased from the geological record? How many innovations were discovered and lost and discovered again? How many groups of humans created something remarkable, lived for generations in ways we'd recognize as civilized, and then vanished without leaving any trace we can recognize? The archaeological record is like trying to understand a 1,000-page book when 990 pages have been torn out and the remaining ones are water-damaged and written in a language you barely speak. You can make educated guesses, you can fill in some blanks, but you're never going to really know what the complete story was, and yet the search continues. Every year brings new discoveries, new underwater surveys revealing structures beneath ancient coastlines, new genetic analyses showing previously unknown population movements and interactions, new dating techniques pushing back the age of sites we thought we understood, new interpretations of old evidence revealing complexities we'd missed. Just in the last decade, we've learned about Homo naledi conducting ritual burials in caves. We've discovered evidence of controlled fire use going back nearly 2 million years. We found tools in the Americas that might predate the supposed first migrations by tens of thousands of years. Each discovery opens new questions, expands the realm of possibility. The story of human prehistory is still being written. There are chapters waiting beneath jungle canopies and desert sands, under ocean waves and inside caves no one's explored yet. There are pieces of the puzzle scattered across continents, waiting for someone to connect them. And maybe that's the most fascinating thing about this mystery. It's not solved. It's not done. It's alive, evolving with every new excavation, every new technology, every researcher willing to question what we think we know. Before you go, I want to hear from you. What part of this mystery fascinated you most? Are you listening from somewhere ancient civilizations once thrived? Drop a comment and let me know where you're watching from. And if you enjoyed this journey through humanity's lost chapters, hit that like button and subscribe. There are so many more mysteries to explore, so many more stories that history forgot to record. Because here's the final truth. Every human alive today is connected to those ancient ancestors who survived impossible odds, who endured climate disasters and near-extinction events, who somehow kept the spark of humanity alive through the darkest times. Their story is our story. Their mystery is our mystery. And somewhere in the gaps, in those silent millennia we can't fully explain, lies the answer to who we really are and what we're truly capable of becoming. The prehistory time gap remains, but the search for answers continues, and maybe, just maybe, the most important discoveries are still waiting to be found.